All right, the Pythagorean theorem. Pythagorean theorem is probably one of the most used theorems in math. Used in algebra, used in geometry, used in trig, used in calculus. You use it for just about every level of math from about the 7th grade up. Now, it is also the most proven theorem in math, which means it's been proved more times and in more different ways than any other theorem. And by proof, I mean, visual proofs, mathematical proofs, actual definite, it works every time. Okay, it's been proven. It's not a conjecture, it's a theorem. Okay, conjecture is assumed to be true. A theorem is proved to be true. Now, a little bit of background on the Pythagorean theorem. It is named after a Greek mathematician named Pythagoras. Even though Pythagoras did not actually discover the Pythagorean theorem. The way that it worked out was Pythagoras had a school. Okay, it was a math and science school. It was very similar to a college. People chose to come study under Pythagoras. You've heard of Confucius before, and people came and studied from Confucius and other people as well. They had their schools. Pythagoras had a school. Now, when people came to study under these professionals, it was almost like a cult. They kind of worshipped them. They loved them. They owed them everything. It was just one of those things where they were learning from this one person. There wasn't the internet to learn from multiple sources. They learned from one person. They told them everything they knew. So, when one of Pythagoras' students discovered the Pythagorean theorem, and he loved his teacher so much and gave him all the credit for him being able to discover it, he actually named the Pythagorean theorem after Pythagoras. Okay, and still to this day, we don't know who actually discovered the Pythagorean theorem, other than the fact that it was one of Pythagoras' students. One proof that has been seen, and I don't have an example of this for you, but the way they used to measure things, instead of having a ruler, what they had was they had a string. And every little bit they tied a knot. Okay, so it's a string full of knots. And what they discovered was that if they took 3 knots down the side, now this is a string, and then connected, and then had 4 knots, then to connect these 2 sides, it would take 5 knots. Okay? So when they did this, actually, I should have an extra knot there. Yeah. All right, so that would be 3, 4, and 5 knots. Okay, and they discovered that they could create a right triangle by doing this. Or they discovered they could create what was a 90-degree angle. And this helped them build things and so forth and so forth. Okay, they didn't have a square piece that they could go and make sure that they had a 90-degree angle. They used these strings to make sure that things were built correctly. And also they used their string to measure, how long something was. They used it for just about anything, marketplace, so on and so on. That was one proof. That was one of the original discoveries of the Pythagorean theorem. All right, so the Pythagorean theorem deals with right triangles. And a right triangle, you have certain things that you have to know. All right. The main thing is you need to know what the hypotenuse is. All right. That is the most important part, being able to identify the hypotenuse in solving any problem dealing with a right triangle. Now, It's always the side opposite of the right angle. What do I mean by that? If I take the right angle, there's the right angle, and I look directly across from that right angle, I have a side. That side is always the hypotenuse. There's no exceptions to that. The hypotenuse of a right triangle is always directly across from the right triangle or from the right angle. Now, the other two sides are called legs. All right, the other two sides are called legs. The legs, the actual definition of the leg is the two sides that make or form the 90-degree angle. You see where those two sides meet, the 90-degree angle is formed. That's the definition of a leg. Mm-hmm. All right, so a leg, and a hypotenuse. Any questions about how to identify those? Without identifying, you're not going to set them up correctly. No? All right, the Pythagorean theorem. In example 1, it says you have a 20-foot ladder. It says for the ladder to be used safely, it must extend 3 feet above the roof. It says, is the 20-foot ladder safe enough for the wall of the house, or if the wall of the house is 14 feet high? Now, this is the roof. All right, there's the roof of the house right there. Here's the ground. The ladder extends out 5 feet from the wall. All right, and the wall is 14 feet tall. And what we've done is we've created a right triangle. The side of the wall, the space, the distance between the base of the wall and the base of the ladder, and then the distance from the top of the roof to the ground. Now, what we have to determine is if a 20-foot ladder is safe enough. We have to have enough space to cover the distance x plus 3, and it's got to be less than 20 feet. You understand why? All right, we have this distance plus 3 has got to be less than 20 feet, because if it's less than 20 feet, or if the distance is more than 20 feet, I don't have enough ladder to make it safe. For example, if x was 20, I wouldn't have that 3-foot extension, would I? All right, so what I need to do is I need to check to make sure x is not, x plus 3 is not too much, is not more than 20. So I have a right triangle, so I can use a squared plus b squared equals c squared. Now, the first thing I need to identify is the hypotenuse. If I look directly across from x, or sorry, the 90-degree angle, I have x, that's the hypotenuse. All right, which means 5 and 14 are legs. Now, does it matter which one of the legs is A and which one is B? It does not. I'm going to tell you one thing that I always do. I always put the lowest number first. All right. So 5 squared plus 14 squared is equal to x squared. I have 25 plus 196 equals x squared. Now, one habit that people get into is they get to going too fast, and they tell me that 5 squared is 10, or 14 squared is 28. 5 squared means 5 times 5, not 5 times 2. All right, so slow down. Make sure you're doing what you're supposed to do. Now, 25 plus 196 is 221. and that's equal to x squared. Now, how do you solve? Are we solving for x squared or are we solving for x? We need to know what x is. So how do I get x squared to become x? I take the square root. And if I take the square root of one side, I need to take the square root of the other. So the square root of 221 is equal to x. Now, the square root of 221. Is that a perfect square?
No.
It is not. So what I can do is I go into my calculator. I'm going to go second square root 221. And I have 14.86606.875. I'm going to round to 2 decimal places. All right. I'm going to round to 2 decimal places. So this becomes 14.87. Okay? Now, what we need to determine to answer this question, we need to know, is x plus 3 greater than 20? If x plus 3 is greater than 20, then the answer is no, the ladder's not enough. If x plus 3 is less than 20, we're good. So, 14.87 plus 3, that gives me 17.87. Is the ladder tall enough? Huh? Yes, the ladder's tall enough. 3 feet added to it. Because see, I'm actually going to have, the ladder will actually extend 3 feet past the 3 feet window. Say I have a little less than 3 feet up. It's got to extend at least 3 feet above the roof to be safe. It can be more. All right, any questions?
So we got that answer, but we did that square root jump, and it said it had to be at least 3 feet, so that's less than 20.
Yeah. Like I say, I would have gotten like 18 and then added 3 to it, I would have gotten 21. Well, if this distance right here, this distance, the x plus 3, that's got to be 20. That can't be more than 20 because the 20-foot ladder, that's got to be covered by the 20 feet. All right. Well, since this is only 17 or almost 18 feet, that 20-foot ladder is going to cover it. Let's see, here's, if that's 18 or 17.87 and that's a 20-foot ladder, that ladder's tall enough. You can clearly see the ladder's taller than the actual space that's needed. Makes sense now? All right. Because as we all know, ladders can be dangerous, right? Not tall enough, not sturdy enough, so forth and so forth. All right. Number 2, it says find the length of the diagonal of a square. All right, if I have a square, I know that all 4 sides are the same. Let's call those values x. Well, I need to find the length of y, which is the diagonal. Now, here's the most basic problem. Let's take a 1 by 1 square. In a square, the diagonal is what? No, the diagonal. What's the length of that diagonal? If you take a square and cut it in half, how long is it?
90.
The length. If this is 1 inch and this is 1 inch, how far do I cut the diagonal? Is it 2? 1 inch? Is it one all the way around? It is 1 inch all the way around, so is the diagonal 1? Why not? It is? You sure? You'd be willing to put some down on it? Put some bonus points down on it? It's 1. Yeah? What if I take away points if you're wrong?
I'll make that.
You're not going to do it? Well, let's find out. Alright, if I have x, x, and y, alright, then I know that x squared plus x squared equals y squared. True? Leg, leg, hypotenuse. Square them all. Now, I'm going to combine my like terms. X squared and x squared give me 2x squared equals y squared. I want to know the length of y. So I take the square root of both sides. So y is equal to the square root of 2x squared. Now, one fact about square roots. A times b can be broken up into the square root of a times the square root of b. So I'm going to break this up. That's 2 times x squared. The square root of 2 times the square root of x squared equals y. Is the square root of 2 a perfect square? No. Is the square root of x squared a perfect square? What is it? So x times the square root of 2 is equal to y. Alright, so in terms of x, I have x square root of 2. Alright, so y equals x square root of 2. So let's go back to that question. If I have 1 and 1, what's the length of the diagonal? What is x? 1 square root of 2, which is just... How about the square root of 2? Right? Who said that? So what if I have a square with 3 and 3? What's the hypotenuse going to be? How about 3 square root of 2? Well, x square root of 2. Whatever the leg lengths are, multiply the square root of 2 by it.
You get the 2. And you got the 3 from the. So if it was 9, it'd be
9 square root of 2. Yes. So the length of that diagonal that you all were just positive was 1 is actually about 1.4. Now, here's the reason why that's important for us to know. All right, and this is where all this comes into play. If I take the coordinate plane, all right, and I draw a line segment here to there, can you just count that distance right there? Can you just go, all right, right here, that's 1, that's 2, that's 3, that's 4, that's 5? No, it's not. Why can't we do that? Because even if it was a perfect diagonal all the way down, we're still counting by square roots of 2. We're not counting by 1s. Now, if I go perfectly sideways, can I count? If I go vertical or horizontal, I'm good. But any kind of diagonal, I'm getting into finding the distance. Okay, and that's where the Pythagorean theorem comes into play. All right, you're finding the distance of a right triangle, finding the distance on the coordinate plane. The distance formula, how many of you remember the distance formula? What is it?
Y or x2.
No, I started off wrong. The square root of,
Wait, was that the one we were talking about? The square root of the x2 minus x1.
yeah, it's the square root of x2 minus x1 plus, or sorry, x2 minus x1 squared plus y2 minus y1 squared. And that's the distance. And you'll see where that comes in just a minute, or in a different section. All right, the converse of the Pythagorean theorem. All right, you know what a converse of an if-then statement is. All right, let's roll back up to look at the actual formula. It says, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the length of the legs. That's the definition. The actual theorem says, if a squared, or if you have a right triangle, then a squared plus b squared equals c squared. So if I reverse those two, then what we can say, if a squared plus b squared equals c squared, then it's a right triangle. So you use the converse theorem to prove that you have a right triangle or not. Okay? So not only does it work a squared plus b squared equals c squared given a right triangle, but you can also say, all right, here's a triangle. If a squared plus b squared equals c squared, then yes, it is a right triangle. Now, one thing you need to know, this is probably the most important part of this, C is always, the longest side. C is always the longest side. Because you don't have a right triangle. All you have is a triangle. So which one is, you don't have the 90-degree angle because you're trying to figure out if it is a 90-degree angle or not. So what you have to know is that C is always the longest side. Now C is the hypotenuse. So let's say you have these three numbers. The longest side is going to be C. And yes, a squared plus b squared equals c squared. Then that C would be the hypotenuse. And that would tell you where to put the 90-degree angle. Now, a Pythagorean triple is when you have three integers. All right, three integers. So, for example, the most basic Pythagorean triple is 3, 4, and 5. All right, that's the one that I used for the example on the board. All right, 3, 4, and 5 will always work. 6, 8, and 10 also work. That's just a multiple of 3, 4, and 5. All right, that's the most basic Pythagorean triple, and then multiples from there. Now, in example 3, it wants to know you have triangle ABC. So I have A, B, C. It says AB is 8, BC is 15, AC is 17. And it wants to know if this is a right triangle or not. So, A squared plus B squared, and we want to know if it's equal to C squared. Well, which one's going to be C? That's going to be C. Let's call that B. Let's call that A. So 8 squared plus 17 squared, and we want to know if that's equal to, sorry, that's 15, equals 17 squared. 64 plus 225, we want to know if that's equal to 289. Now, when you add these two numbers up, you get 289 is equal to 289. Is that true?
Yes.
Would you say that a squared plus b squared is equal to c squared?
Yes.
Yeah, so this is triangle ABC is a right triangle.
So they're equal.
If they equal each other, they're right. If they don't, they're not. All right. Now, one thing that you can do when using this basic idea is what happens if a squared plus b squared does not equal c squared? It's not a right triangle. However, you can classify a triangle using that idea. If a squared plus b squared equals c squared, then it's a right triangle. We just learned that. If a squared plus b squared is greater than c squared, it's an acute triangle. If it's less than c squared, it's obtuse triangle. Yeah, you need to have those three. And then your last three examples. All right. One way I remember, one way you can remember this is always think the opposite. Because acute usually means smaller, right? And obtuse normally means bigger. But look at the signs. Acute is greater than. Obtuse is less than. All right, that's how I remember it. Learn it however you need to learn it, but you need to know. All right, a squared plus b squared is greater than c squared is acute. Less than c squared is obtuse. All right, so that's A, B, and C. So 21 squared plus 28 squared, and I want to know if that's equal, less than, or greater than 35 squared. So what I can do is I go to my calculator. I got 21 squared plus 28 squared is equal to 1225. All right. Now I do 35 squared, and I get 1225. So what I now know is I know that 21 squared plus 28 squared is 1225, and that's equal to 1225. So if it's equal, then it is it's a right triangle. All right. I got 3.6 squared plus 4.8 squared. We want to know if that's equal to 6.4 squared. All right. 3.6 squared plus 4.8 squared is 36. So we want to know if 36 is greater than, less than, or equal to 6.4 squared. 6.4 squared is 40.96. So 36, or a squared plus b squared, is less than 40.96. So a squared plus b squared is less than c squared. That tells me this is obtuse. All right, and the last one, you have 25 plus 144. All right, when I add these two together, I get 169 is less than 196. So a squared plus b squared is less than c squared, so it is also obtuse. Questions? All right, your homework's page 280, 5 through 17 odd, and then 19 through 22 all.